Hello and welcome to this video where we're gonna be going into the data science part of this course with the first lecture on data basics. Today I'm gonna show you a lot of things that you've probably already seen in DataCamp, but we're gonna go through everything just so you have it and make sure you understand it. So yeah, we're gonna be using pandas, which is sort of the default way of working with data in Python, and it's also part of the Anaconda package, so you should already have so it should be installed on your computer already if you download Python through Anaconda. And yeah, pandas is like the default way. It's extremely popular. There are other ways of handling data in Python, but that's mainly sort of for later stage. If you're working with giant data frames, then sometimes they can be more efficient packages. But pandas is the most used, so it's easier to get help, and it's actually, I would say, also easier generally to use than other packages. Just how it's implemented and the syntax and everything. But the main thing is sort of in open source programming that if everybody else uses something, then it's easier to use that, because then all the guides and everything will be focused on those packages, the most popular ones. So yeah, we'll be talking about data frames objects and pandas series. And data frames is sort of like, we'll see it, but data frames sort of how you view a data set, sort of two-dimensional matrix. And a pandas series is each column. There are some links to an official tutorial if you want to go more into depth. DataCamp also has a cheat sheet and sort of a bit talking points about using pandas. I think what I like most about the cheat sheet is that sort of they have this nice picture that is relatively concise with a lot of operations that you'll be using generally. So it can be handy to have this on you the first couple of times you're coding data. DataCamp has another course on writing efficient code with pandas. So sort of an intermediate step between choosing an entire different package is to sort of just write better code with pandas. So efficient here basically means that it runs faster. And then there's some history if you want to know more about the pandas project. So we'll be using the pandas package, and then we'll just be using this display from IPython just to show the data frames in a more convenient way. Yeah. So as I said, a pandas data frame is sort of like a data frame that you may have seen in Stata, possibly SAS already. So sort of this two-dimensional matrix and with a bunch of columns which each have a name, and then sort of an observation for example, each person or each person's year or something. And yeah, each column is a pandas series, which is very similar to a NumPy array, and often you can use it the exact same way, which is nice to know, and it's also part of the reason sort of why it works relatively efficient compared to using lists or something like that. And yeah, you can sort of see, I mean, I mainly have this two-dimensional matrix in my head, but you can also see a pandas data frame as a dictionary of pandas series. So you have a key for each column, and then you have a series for the values, and sort of have a dictionary. That's also one of the ways you can create a data frame. So here we create three series or three columns. One is just 1, 2, 3. Another is so that's IDs. We'll call it for sort of identifier. Then we have their incomes for 3 different persons, which are just random floating point numbers, and then you will give them some names, which are string values. And then to create the data frame, or one way to create the data frame is to write pandas.dataframe and then just insert it like a dictionary with what we want to call the columns, their pandas series values, and for each element. And then it looks like this, like a data set. And then you can of course imagine a huge data set with many observations and more columns. Sort of pandas automatically creates an index here on the side, which just counts from 0 to up to how many observations there are. Yeah, and that's not really important. So if you don't display anything, then you have a numerical index. You can also have like an index with names and stuff like that. But the default way is to have a numerical index. Yeah, and you don't actually have to input pandas series. Pandas will sort of automatically transfer them into series. So if we create a pandas data frame the exact same way as before, now we just don't use this pd.series to create pandas series, then sort of the result will be the exact same. Yeah. And you can also create data frames in different ways. This is sort of the two-dimensional matrix way of creating the data frame. So then you just write data equals, and then this how the data frame basically looks. So you have 3 rows and 3 rows and 3 columns, and then you input it as data, and then you just have to give the columns names, and this gives the exact same answer. There are like even more ways to do it. You can sort of look out the documentation for initiating a data frame, and it's just about finding out the most convenient way for you. In reality, you're probably not even gonna be creating data frames like this that much, because you'll see later that you can sort of just load data from a file into a data frame. That's typically what you will do if you have a lot of data. Hopefully you won't be writing it in manually. Data frame is essentially a matrix with rows and columns, an index that keeps tracks of the row's location. You can get sort of general information using the info method. It's sort of mumble jumble. I think the important thing is that you can see the types that the different columns are. So you can see we have 1 float type, 1 integer type, and 1 object type. Float and integer are pretty easy. That will be, you can also see it here, that the ID is the integer type, because we sort of only inputted integers. That's here. Income is a float type, and name is called object. This is Python's default type for strings, and in practice you should only use it when you're dealing with a string, but in reality sort of object can also be multi-type. So you can have some strings, some floats, some nans which are not a number, so sort of empty values. So you should be somewhat careful when using objects to make sure that you only have strings, so sort of you have expected behavior. And yeah, you can use this display to sort of show matrices. So another thing you can just do is just to sort of let it Python output it if you just have it as at the end of your code. But a more like explicit way of showing your data frame is just using this display. Yeah, so how do we access different elements of our data frame? We do that using indexing or subsetting. And this goes back to slicing and logical indices, which is sort of, you can do it on list, but I think we mostly talked about it in the context of NumPy arrays, which was this sort of indexing different elements of a NumPy array or NumPy matrix. And Pandas is built on NumPy, so a lot of similarities pop up. The main way of doing it in data frames is .log. Sometimes you can also use ilog. Ilog is sort of the numerical indexing, so it's a bit unintuitive since you sort of have to remember all the numeric index of your data frame, while log is based on logical, so you can sort of, I'll show you that but sort of based on conditions basically, and then the columns will be name based, which is, I mean, in my view, that's the default way of sort of thinking about data. So here we're thinking, if you have this one, then you're thinking about the income column. You're not thinking about, okay, that's the second column, when you're remembering it in your head. Yeah, here's some examples. So how you would do it with the ilog is using only numerical. Then you can take a slice of the rows, and then you can also take slices, but you can also just select one of the columns. So what this does is it selects rows 0, 1, 2 and column 2. Log is a bit different because you're using names. We can use colon to sort of select all the rows, and then you can select columns here by names, which can just be one name, or it can be a list of names if you want multiple columns selected. So here we're just selecting the column year. So here's a condition. So here you're selecting all the rows where the year is equal to 2002, and you're selecting all the columns, and here you're sort of combining those. You cannot combine logical or numerical indexing with the name indexing. You can sometimes do it with log, because the index can be numerical, and log takes the index as names, but you should generally not do them. Also because the intervals work differently in log than in ilog. So here you get the first 2 observations, while here you will get the first 3. I would just generally avoid it to avoid the confusion about that. And mostly use conditions when you're using log, or select everything. Yeah, and like pandas have a bunch of different ways of indexing stuff and pulling out stuff. My advice would be to just sort of focus on getting to know .log mostly, and then use the others if it's convenient and you remember them. I'll show you a couple of others later. So here we see an example sort of in the flesh in real code. So we have our X data frame from before, then we use .log, and then we select all the rows where the ID is larger than 1, and then we only want the name column. And then we get that we can sort of, if we display our original X, then we can see that we're getting what we want out of it. We're getting out Maximilian and Bobab. Yeah, and that's how it works. And you can sort of, if you wanted more columns, then I would just write it here. And there's a slight difference between having a list of 1 column and just having the name. If you do it like this, then you're outputting a pandas series, while if you have it in columns, so it's in a list, then you're outputting a data frame with only 1 column. This can sometimes be important. Yeah, and if you don't write anything after sort of before you had .name here, but if you don't write anything, then pandas will sort of treat it as if you just wrote a colon, and just select all variables. You can, instead of sort of writing this directly, you can also predefine it. So here we create a Boolean series of true or false values, which is also basically what we're doing here, doing up here, but now we're just doing it explicitly, and then we're using this I Boolean series to select variables. So all the variables where the value is true will be selected. Yeah, a different way to get variables out. So actually already now I sort of missed it, but if you just want to get a series out, then sort of one of the ways is to write x squared brackets of the name that you want. Then you get a series out from the original data frame. This is one of the sort of the extra ways that you can subset. So sort of another way to write this would be .log .colon .the name this gives the same answer. Yeah, and a third way of getting to a variable is to use dot variable notation. So then you just write x dot, then your variable name, and then you get a series of that variable, the pandas series for that variable. Yeah, as I said, like there's a bunch of different ways to do this. Sort of, I think it looks pretty intuitive that you are selecting this variable from this data frame. But when you're writing it yourself, I think it's easier to stick to one mostly, and then as you get more comfortable, then you can start to work on it more. Then there's this little question about why do you think dot variable notation works at all, and this goes into some stuff we've already talked about, which is classes. Maybe it rings a bell. So the answer to this question is sort of that a variable to a data frame is actually an attribute. So it works as an attribute. Because data frames are also classes. And then here's the numerical index. As I said, it's less intuitive for the most part. Here you can see we're choosing the first, or the 0 to the first column, and then the third column, the ID and the name column. Yeah, and remember, if you did this using log, then you would have closed intervals, and now it's half the open. So using 0 to 2, then you only get the 2 first. Yeah. So how to create new variables? The main way of doing that is to use. You can also use the .log, but you can also just write df of the variable equals to something new, and that new thing must either be the same length as the original data frame, or a scalar which will then be broadcasted to all values. So here we can create a year variable. We can create a year variable. So we have the original x looks like this with ID, income, and name. Now we create a new variable called year, which is equal to 2003 for the first observation, then 2005 and 2010. And then we also create a zone variable, which is just equal to 7 for everybody. And you can see that pops up here. And how these values are distributed is sort of along the order of the observations. So Python remembers those. And you cannot write df.newVar equals to something. So you cannot set the attribute directly. And the reason for that is that sort of, although a variable is an attribute to the data frame, Pandas wants you to create it in this way, so it sort of runs some different observations to make it part of the data frame in another way. So if I write this, then I don't get an error, which you would usually get, and you should get, but you also don't get it as a column in your data frame. So I think maybe we need to do it like this. Yeah, okay, just no. Okay, usually you get an error for this because Python sort of knows that Pandas knows that you're trying to do something that doesn't work, or you should at least get a warning. Okay, but this also shows why you should really not do it, because you're not even warned that it's gonna go bad. Okay, so here I try to create sort of like this, a new column, and I insert a list into X, and then in the actual X there's actually no column. It's still an attribute for the data frame, but it's not part of the columns. So sort of that's not the way to go about it. And I can't really explain why it's not throwing a warning. Usually it does that. And yeah, you can create new variables based on old variables. So here we create an adjusted income, which is just the income from before. So this is the entire series. And when you, this is just a mean of the income, so you're basically demeaning it. And this is a scalar, and this is just a random scalar that we added. Then you're broadcasting the scalar onto each row of the X. So we can see that the Vitus sort of makes slightly lower than the average. Maximilian is just above the average, and Boba makes a lot above the average. Yes, that's the most important part. And when you want to assign a new variable or change old variables for only a subset of all the rows, so this could be okay for all men, we want to make certain adjustments, or all men dataset, or before some year we have to take care of some special inflation, blah blah blah, something. Then you need the dot log generally, or the dot ilog. And again, the right hand side, so what you're assigning can either be a scalar, so single value, or a list of values with the same length as the number of selected rows. So here we sort of take out a copy of X. This is just to avoid overwriting it. And then we're only selecting the first four, so we're only selecting these columns. So we're just avoiding the new columns that we created. Yeah, and then we create an I data frame, which is just the first four columns of the X, and an explicit copy. And then we sort of, for IDs larger than I, then we rewrite the name to no name. So then you can see that, okay, if the ID is 2 or 3, then you have no name in this data set. And you can do that as well to multiple values. So here we recreate I, Y again, and then we say, okay, if your name is Vitus and the year is 2010, maybe that's now all the years 2010. Don't know why it says 2005 there. So we just create it in 2005. But then we have this Boolean variable for those conditions. So for Vitus, or year being 2005, first we print the subset. So the original data frame is printed, the data frame where the conditions are true, so that's for Vitus and Maximilian, and then we can assign, we can give them new names, Bip and Peter, and then we can look at the final data frame where Vitus and Maximilian has changed name to Bip and Peter, and you can sort of, I think that's why it was 2010. You can sort of see, okay, here it's just the first two names that have changed, and we've given it two new inputs. But that's not sort of how it works. It works on this conditioning. So if you choose 2010 instead, so you choose to change the name of Bobab, then you're still just inputting through two inputs, a list of two inputs or two elements, and now you're changing the name of Bip and Peter, or the names of Vitus and Bobab into Bip and Peter, and Maximilian is unchanged. Yeah. Then there's a slightly important thing about copies and views, and it's just sort of mostly that you should be aware of this, and also what you should know when you inevitably make some code that creates something called a setting with copy warning. Yeah, and we've talked about copies and views before. So a copy is sort of if you create a new variable, a new object which sort of is the same as the older object, but it's completely separated. So changes in the new object does not create changes in the old object. While views is sort of a view into the old object. So if you create a view of an original, so you have an original object, then you create a view of that object, and then you change it, then you're changing the original object also. You should be somewhat careful when doing this in pandas, but usually it will just throw you an error or warning to sort of warn you that you might be doing this, or you might think you're doing it, but you're not actually doing it. There's also this thing in pandas where it's actually slightly unstable whether or not it returns a copy of you. It depends on your machine and your memory usage and stuff like that. I think it's generally, you should not assume anything, so you should check your code, and you should try generally to use something that returns a copy, and otherwise change the data frame directly in one line. So the reason that this can be an issue is that sort of when you're looking at the data, then it's natural to not use .log, which generally returns a copy, pretty stably returns a copy. And then you can sort of say, okay, I just want to look at 2 of the columns in the data frame. That can be you sort of have an overview, and then you print that, and you can sort of index that your already indexed data frame, still not using log. So you think, okay, I only want 2 variables, I only want some of the columns, and this is fine when you're just looking at the data, not changing anything. But when you're actually doing assignment, so assignment of new variables or changing of variables, then you should be a bit more careful and not just sort of create new variables and make changes in them and hope the changes sort of revert a base comes back to y. Yeah, so go back to x. If we create a copy of x, and we sort of we make a Boolean index from our new copy y, and then we can create a subset of y by indexing this, and then we maybe, okay, we want to change something in set 1 because we've been looking at it and something is wrong. This will create a warning message, and the reason for this is that it's sort of unambiguous whether or not this change in set 1 creates a change in y. And the reason it's unambiguous is because you don't know whether or not it's a view or copy. It's a copy on my computer, but interestingly, from last year's lecture, it was a view. And I think this is something with my computer relative to other computer might be an update in pandas. And this is why it throws an error, because it's sort of it's ambiguous what exactly you're doing. And in this case, it's a copy, so there's no change to y. So what we did was we called all the names test. So in set 1 data frame, then all the names test, but in y there's all the original names. Another thing that you shouldn't do is to sort of do it directly in one line. So this is basically doing the same. You're sort of creating a set up here, and then you're just assigning its new value by sort of doing chained assignment. So first you're taking the name column from y, and then you're taking the conditional rows, and then you're saying those should be equal to test, and this will throw a warning from NumPy, but it will not change, and it will throw a warning, and it will not change what you're trying to change. So here we're saying that if ID is larger than 2, which is for Bob, then you should reassign the name to test, and that's not happening because you're using the sort of chained assignment stuff. And it doesn't work in this case because this code sort of returns a copy of the y, and then you're assigning something new to y, but you're not changing y. It works down here if you just extract using just single columns. So you're extracting a panda series. That series will be a view into y. So you will be changing y. So you can see here now the name is test. But you also get an error because it's a bit ambiguous what's happening, and Panda sort of warns you that you may not be doing what you think you're doing. yeah, another way you can do this directly is if you use lock to sort of create these sub indices, then you'll usually get a copy out. Again, you might not be even able to recreate these exact errors on your computer. This is just a warning that you shouldn't do it, but at least on my computer, when you use lock, then you are sort of returning a copy, and when you change that copy, you don't get an error, but you're also not changing the original data frame. So what I would do here in this specific case, if I actually wanted to change only set2 and not change y, to sort of would be to explicitly output a copy. Because in other cases, something like this can happen, where we just recreate y to make sure it's the same as up here. Yeah, and then we are doing the same conditional indexing, and then we're creating a sub data frame set, or it's actually a series, and then we're changing that series, and because we're sort of indexing this way, then you're actually also, then it's a view, so you're also changing y. What you can see here, we still get the warning, and then we can see when we display y, as we do here above, then the names and y has also changed, even though we sort of used a copy of x, which has the original names. I think my solution here, if you only want to change set, then you would do what I talked about, using a copy, sort of explicitly make a new data frame, which is a copy of the old data frame, or sub copy, and then you change the new data frame however you want it. If you actually want to change the original data frame, then you shouldn't use this change assignment stuff. You should just do it in one go, and usually that's using lock. So you sort of both select the rows that you want and the columns that you want, and then assign the new value in one line and in one sort of lock statement. That's more. So what you get out of this is you get no error, and you get the change that you want, if you want it. Yeah. That's just, I mean, you gotta get a setting with copy warning at some point, I'm sure. But now you know, at least have an idea of what it's about. You don't have to understand all these warnings and why exactly they happen, you sort of, but you have to understand the issue there is with views and copies, and sort of doing this gets around it, because you're sort of assigning directly the data frame. You're not creating a copy of you and then assigning. And that's also what happens when you're doing it in one line like this. Then there's the index I mentioned a bit earlier, that Python sort of gives you a base index, just counting from 0 to some number, how many observations you have, and that it does that automatically, and that's nice. The index is sort of a nice way sometimes to access the different rows, and it's not, I mean, it's okay when it's a numerical index, a range index, but it really comes into its own when you're actually assigning the index based on another variable. And this can sort of, I'm gonna just show you what it is, and when you get deep into it, then you can have like multi-dimensional indexes or indices and stuff like that, and then it can get really useful. But I'll show you with one dimension. So you're sort of assigning one of these columns to be the index variable, so the unique identifier of how the data set is structured. So you might remember before we had sort of the index here with no name, and then we have the column variables. If you want to set, so now we're creating a new data frame where the index is the variable name that we have here. Then sort of looks like this. So you have the index here, sort of explicitly the first column, And then you have the index values, which are the names just coming from the old data frame. And then you have the variables of the data frame set above here. And you can sort of specify that also just when you're creating it. So instead of writing a bunch of columns and then set index, and you can also just say I want this data frame that I'm creating to have this index. And now you can access the index, for example, using log. So this would be the condition part of the statement, and then instead of condition, then you can have an index value or a list of index values. I'm pretty sure you could also do it like this, and then you can take another name. Oops, and now you have the two names, and you're outputting both of them. And you can see the values. So you access the index by y.index, and then you choose the values. Yeah, another thing, you can also do conditions based on the index. That's still possible. That would just be y.index equals to Vitus, for example. It's not strictly necessary, I think, to write the values. Then you get sort of so values extract the values in a list or a NumPy array, while if you just write .index, then you sort of get an index object with a bit more information. Yeah, but doing conditional works the same, whether I should use .index or .values. Yeah. Boom, boom. I think that was sort of the basics of indexing. And now, as I told you before, Panda sort of builds on NumPy a lot, and some of the objects or the classes are very similar. For example, series, which are very similar to a two-dimensional NumPy array, or one-dimensional NumPy array, so vector basically, and it has a lot of NumPy functions, and a lot of NumPy functions works on it. It has a lot of NumPy methods and functions work on it, but it's also possible to extract the underlying NumPy objects, so getting the series out. So if DF is a pandas data frame, then you get a pandas series. If you just sort of index it like this, taking out one variable, and then you can get the variable or the NumPy array from that series by writing .values or toNumPy. So there's a toNumPy method, but there's also just an attribute called .values. Yeah, so this is just basically showing you that if you extract the income Panda series, then you can make it into an NumPy array. And it's the exact same if you're using .values. You can also create a list by sort of unpacking the values and putting them into a list. So you're unpacking using the star, and then you are creating the list using the square brackets. Yeah, so a lot of this has been sort of basics, underlying data frame objects. What are they? How do we index information from them? Now I'm going to show you how to actually calculate something new from your existing data. Or some ways of doing that. The most intuitive thing in my head would be to use row by row functions. They are not always the most efficient, but hopefully they make sense for you to see how some of this stuff works. Yeah, so we create a new data frame, and then we create a function which takes a row as an argument. So sort of you can view it like the row. Yeah, this is the row. So you this is the Vitus row. So you have his ID, his income, and his year And this function sort of takes that as an argument, and you can subset each element of the row in the same way as you would access columns using the names, the squared brackets, and then you can use apply to apply this function for each row. And if you want to do it for each row, then you need to call access equals to 1. That's just sort of one of those things. It's also sort of in the documentation which access you want to access. And the other access would be sort of doing it column-wise. Yes, and then you get out this function which sort of takes the year in a string format and separates it by line, and then takes the name which is already in the string format. Yeah, you can also, as I said, the underlying series and NumPy arrays, build on NumPy arrays, and you can also sort of create functions that just makes calculations directly on the NumPy arrays. So here's a function that takes ink and year, and assumes that they are the arrays from ink and year, or array format of the ink and year columns, and then it just multiplies ink, each element of ink, with the max value of year. So it's not a sensical multiplication really, but it's just to show you how it works. So we're taking 2019, which is the maximum year of all the observations, and then we're multiplying that to each element, and then we're getting this out. And this actually, because the Panda series has a lot of the functionalities of NumPy arrays, then you don't actually need the NumPy array. You can also just run it like that. It works the exact same. In this case, that's not always the case. You can test that out. You could also NumPy p sort of just use np.max instead of using this method. You can use the NumPy function max directly, and oh yeah, we need to run it, and that gives the exact same. So a lot of different ways to get to the same destination. A third way you can do it, which I don't recommend generally, is using assign. I can see I misspelled assign also. Yeah, assign is similar. You can sort of, and it's just a method from the data frame, and then you create new columns as keyword arguments. So you're saying assign, and then you have the first argument, you give it some name, which is just the name you want for your new column, and then you give it a function, and that function takes the entire data frame. And the reason I don't like it is because it creates a new data frame. It's not sort of changing the existing data frame. So you can see when I run this, then you get an I2 with a new column, but it doesn't change Y1 or Y. That still has the same number of columns. And that's sort of very memory inefficient, because of course you could just write Y, but then you're not changing Y here. You're creating a new Y each time you're assigning something. While with the other methods, then you're just adding this one extra column to it, which is generally more efficient. It's not that important in the stage where you are at now, but it's quite important to sort of build good habits now, because you're probably not going to be working with like huge amounts of data where it takes a lot of time to run anyway, even though you're not efficient. But I think this is one of the points where it's just easier to learn it this way, and then generally not use assign unless you're sort of creating a new data frame anyway. Yeah, that was everything for this video. on sort of the rudimentaries of pandas and data frames. Thank you for watching.